Good afternoon, everyone. And I want to thank the 4G World and UBM and Verge for inviting Ken to give the presentation and also for allowing me to give it in Ken's absence. So I'm going to be talking about what we at Nokia Siemens Networks call the gigabyte per day revolution. And this is our extrapolation of the network and requirements of the network towards the year 2020. I'll be sharing our vision of why we think that's a good target for the industry. It's certainly a good target for us, and also talk about how we intend to solve those particular problems or address the problems and challenges. Okay, so this shows that the future is arriving faster than ever. If you look back in the 1980s and 1990s, obviously most of the mobile communication was voice in nature. We started to see a slow ramp up in the late 1990s, 2000s for mobile internet, mobile data, but it really took off in January 2007 when the iPhone was introduced as a solid phone that users felt very comfortable with, and it really helped, along with Android, to grow the hunger and thirst for data in the network. And you can see here the applications. The applications have grown significant, and we will continue to see significant growth in applications. And this future of 2020 is arriving faster than we expect. And we call this the thing that's motivating this the engagement economy, whether it's social economy. All of us want to take our experiences and take them, number one, mobile, but also socialize them with our friends, our colleagues, our family. And the mobile networks have to be capable of handling this vast amount of traffic. That includes data, or bearer as we call it in the industry, as well as control, all of the updates, all of the synchronization, so all of those messages that work between our UE device or our smartphone and the application server. Now we see that 3 billion social media profiles are in existence globally, and that includes 1 billion active Facebook users, of which 600 million are mobile. So higher than 50% of the Facebook accounts or active users, I should say, are mobile. We also see that people are sharing their photos over Facebook, over 200 billion photos, 300 million uploads per day. And if you look at it again, everyone wants to take their experience to their family and friends. I have 2 kids in college, and I just uploaded something for them today, some photos for them to take a look at, some work on our house. So that equates to 200,000 photo uploads per minute, 3,500 per second. Now, Twitter has become popular. It's the second most popular social networking application in the US. We see 500 million Twitter accounts on the order of 11 new accounts per second, 200,000 tweets every minute. My daughter, who's a senior in college, tweets all the time. I'm not following her, but she does tweet. She has some kind of following, which is kind of interesting. And then Pinterest. Pinterest is one that is coming on. It's the third most popular social network here in the US. Now, many of us are on LinkedIn. LinkedIn is popular for the professional crowd. And we see 175 million LinkedIn users, of which we get 2 new ones per second. And 62% of the LinkedIn accounts are from outside of the US. And then YouTube. 4 billion, YouTube views per day. Obviously another popular application amongst all of us for sharing videos worldwide. So all in all, the engagement economy, the social economy, and it's this social networking and the thirst for interactivity on the network and all of the data on the network that drives our requirements as we move towards 2020. It drives, I can tell you from an NSN standpoint, CTO standpoint, it drives the requirement for the research and advanced technology work that we're doing for the future. So the important thing is that it used to be that content was owned by content developers that were mainly commercial in nature. And all of us know now that we are all content creators. We all upload. We all work to expand our social network and expand our data to provide a rich experience and have people understand and feel that experience that we have. We are connected wherever we are. One of the interesting applications that we're looking at in NSN is that of large, what we call high-density public venues or stadiums. And there you would think that maybe our first thought as we were looking at football stadiums and baseball World Series and trying to maintain connectivity there and good quality of experience is that downlink is the problem. We're thinking people want to see different views or replays, et cetera. But with the age of jumbotrons, that's really not the true requirement that we're addressing. It's more uplink. People, again, wanting to share their experience with those that are not in the stadium. So a note here, the content we are so proud of can be uploaded and then accessed anywhere by anyone that we want to access that information on any device. Networks include individuals. We have to be able to support groups and increasingly machine-to-machine communications. So this leads to this, what we call the 1 gigabyte per day revolution by the year 2020. And that includes 1 gigabyte of user data for every mobile. And we as a network provider need to be able to supply that in obviously a profitable fashion, but in a profitable fashion for our customers, our carrier customers, and all those that are providing network services. And this leads to a requirement that the network itself support about 1,000x increase in traffic, 1,000x increase in traffic. And you'll see that these are driven by folks using various devices. You can see a smaller and smaller sliver. I don't think I have a pointer here, but smaller and smaller sliver for voice calling. More video. Video is the application, if you will. Downlink as well as uplink. More business data, IP-based calling, online gaming, et cetera. Future traffic will be much more prolific as we move along. So what does a gigabyte look like? Uh-oh, I think I'm out of sync here. Pardon me. Yeah. Sorry about that, folks. This is the problem with giving someone else's talk, okay? All right, I think that's right, thank you. So don't move it yet when I click, if you will. All right. So I talked about this. All right, so what does a gigabyte look like? And I mentioned social networking. There are more and more musicians that are obviously putting their content on the network for others to hear and utilize, at least in some of the R&B world, for sampling. It is 1 gigabyte is 200 songs, gigabyte 1,000 digital books, 4K Facebook pictures, and 50,000 emails, maybe less than that with attachments. And what will be next? Obviously, more and more of your information stored in the proverbial cloud. So cloud computing. And that allows us to be able to provide that information to all the devices anywhere that you are and those users that you select that you want to see and have access to that information. Always on social gaming, more 3D mobile video. 3D for a while had taken off from a commercial television industry standpoint. It certainly has taken off from a movie standpoint, and we're expecting that that will finally make its way into our mobile world. And then more what we call fringe types of internet access or internet devices and the Internet of Things or machine-to-machine communication. So the one question then is, how do we build networks of this type? I mentioned that if you take the gigabyte per day, and I spoke to, I guess, 4G Americas a little bit about this before, but if you take this gigabyte per day revolution and then you step back and look at the network implications, what you see is that the need to support on the order of 1,000x capacity. We also see that because of that, we've got to make networks that are more efficient, more efficient utilization of resources within the network. For peak rates, for these things, high bit rate services like 3D gaming, 3D video, we need to be able to support gigabit per second peak rates. Another thing is reduced latency. So as you go from HSPA, as an example, the single link latency for HSPA was on the order of 100 milliseconds. As we move to LTE, that same equivalent measure went to 10 milliseconds. In the future, we're through faster and faster processing, smaller frame rates. We want to be able to support a single millisecond of latency. And that's for higher degrees of interactivity. Because we expect these services and applications to not just be higher bit rate and large file transport in nature, but also more interactive in nature, which leads us to the need to reduce latency as we move forward. Of course, we've got to continue to reduce energy as we drive these networks and build these networks. One of the areas that Nokia Siemens Networks really pushed forward this year was the notion of liquid networks. And this follows that kind of architecture where the networks need to be self-aware, need to be more aware of the content that is being transported in the network, adaptable from a quality of experience standpoint, a time of day standpoint, types of applications supported, et cetera, et cetera. So that, again, leads to more intelligent, more adaptive type networks, a la liquid nets, as we call it, or liquid networks. Of course, we have to deliver superior customer experience. And in order to deliver superior customer experience, you have to know what the customer wants and have some insight into the customer, who that customer is. And so if you step back from that, you need more analytics to, first of all, be able to understand the customer and understand the habits of the customer, and then build on those insights to be able to provide a better quality of experience for each unique individual customer. So predicting all these use cases is impossible, as we know. Now, we're looking out to 2020, and I like to say that that is 8 years from now. If you look 8 years ago, that was 2004. And you could see at that point there was some ramp up in, as I mentioned, in smartphones, but realize that the iPhone was introduced in January of 2007, 3 years later. So there's a lot that's unknown here, a lot that is projected. And our job is to try to project that and build the networks to support what we think the future holds for us. So this 1,000 times more traffic, how do we break that down over the next 8 to 10 years? First is that we expect a 10x improvement in spectral efficiency. And this is what we do. This is what I do every day as I go into the office. My colleagues, some of my colleagues are here. A lot of work on advanced antenna processing, higher order or smaller TTI frames being able to do repeats more often, coordinated scheduling in order to reduce interference. All of these are things that we're doing in order to handle that last box over there, which is 10 times more spectral efficiency. At the same time, we will also be adding 10 times more sites. You know, our projection is that the 80% of the new sites that are going to be deployed over the next 8 years will be small cells, where you can concentrate your network towards those users that need the capacity, network capacity. And we think with the advent of small cells, more concurrency in the network, that we'll be able to get 10x improvement or 10x traffic throughput just based on small cells alone. Then the other is 10 times more spectrum. And this includes new spectrum allocations. Again, 3GPP is focused 6 gigahertz and below. So we expect some of the swaths globally will be opened up. We've spent time trying to advocate for some of the new spectrum in the US. Of course, with carrier aggregation, we can get, again, more efficient. We get trunking efficiency with respect to that larger amount of spectrum. So all of these together are kind of benchmarks as to what we think we can do in order to achieve this 1000x capacity increase. And as I mentioned, networks need to be flexible or liquid, as we tend to call it. And that includes capacity flows with traffic, and that traffic could be based on time of day, user applications, more insight with respect to those users, where those users are, and the types of applications and services that they require. And then higher efficiency, lower cost, but most importantly, superior customer experience and gaining insight into the customer experience, which I claim will be one of the next avenues or challenges for our industry. But even as we spend more effort to know and understand our customers, the perfect and efficient network is not always enough. And we want to, as I mentioned, understand more about traffic characteristics, use cases, when certain traffic patterns occur. But also we need to have better insight with respect to our customers themselves. What are they doing? When are they doing it? Who are the important customers that we need to service from a carrier standpoint, which automatically or incidentally obviously means the kinds of applications and requirements that we will need to provide in our network equipment. And the operator will need to be able to manage customer service qualities and experience and understand those devices that the customer has in for services and applications. So we need a revolution in customer experience management. Okay. And that includes the ability to be able to collect and analyze data. This is part of the effort that we within my laboratory and the larger NSN laboratories are focusing a lot of effort on. Analytics, sorry. Then we need to turn that data into insights about the customer. So learn more about the customer themselves, habits, use cases, applications, et cetera, traffic patterns, and then turn that into insight with respect to the customer needs and desires. And then be able to use those customer insights in order to better optimize network traffic and be able to provide a better quality of experience for those individuals, first with our equipment and, of course, through carrier deployment. So this is the bridge to the gigabyte revolution. And we need to make decisions today that will define our future. And you know, I've kind of talked about bridges in this fashion before. You know, some of you maybe have heard this, but you know, when I was a young engineer just fresh out of school, I remember talking to one of the senior members at that time, and you know, one insight that he provided is you can't really judge the number of people that will use the bridge by those that swim across the river. Okay, once the bridge is there, a lot more people will figure out how to use it, more so obviously than those that swam across the river before the bridge was there. So this is it. This is Ken's presentation, my presentation. Thank you for your time. Hopefully it was insightful.
Bill, thanks so much for filling in. By the way, they tried that up in Minneapolis, and the bridge collapsed. You know?
Yeah. Well, I'm not talking about a bridge to nowhere, no Alaskan bridges, but no politics. So, you know, I know this is a time of politics.
I think Bill reserved a couple of minutes just for Q&A. Does anybody have any questions? So NSN has this concept of liquid networks. Sure. And we've been, you know, all struggling with how does that really describe the operator environment that they find themselves in once they've jumped in and gotten liquid. So what does it allow an operator to do differently than a conventional 4G network?
So liquid network, as we call it, you can break it up into liquid radio and liquid network architecture and virtualization itself. The point is, if you look at our features, if you look at our roadmap from a product standpoint, that roadmap shows the adaptive nature of supporting a liquid type of network. We're taking strongly into account and taking to heart this notion of self-awareness, optimization, and adaptability. So I can't say that, you really just kind of have to put, take it all into context. And what I expect from a carrier standpoint or anyone out there, they look at the list of features that we are advocating and what we are developing, and you'll get a sense of just where we're going. That with respect to this awareness and adaptability and then optimization. So that's kind of the context of it. It's not really something that, it's evolutionary, and we capture it with respect to our roadmap.
So is it something that an operator can only benefit from if they're building a greenfield network, or can they take advantage of it as a part of an upgrade or a transformation of an existing network?
If you look at the I think we made something like 8 announcements NSN did this month on that order. A couple of them were upgrades. One, WCDMA upgrade, if you will, for higher rate HSPA, and the whole notion of more efficient scheduling. The point of that, again, is this self-awareness and adaptability, and that goes to answer your question. It's not a greenfield. It's not necessarily new product, but product evolution as well.
Fantastic.
I got a question, if you don't mind.
Great. Go ahead.
Yeah. So one of the things I was wondering is whether or not you're working in the area of network intelligence, in that you're getting to know the customer so that you can anticipate what they'll be doing. So ahead of time, kind of like the bandwidth accelerators that are being used in the IP network. In short, you're effectively caching and spoofing and upping the apparent bandwidth.
No. So we hope to be able to get there. Obviously, the first step is to gain that insight and understand the KPIs, instantaneous KPIs within the network or the state of the network. And then if you have the ability to be able to do optimization or transcoding, be able to take advantage of that. You may not be able to, so that means that maybe you introduce some sort of QoS. You introduce new bearers or dedicated bearers in order to be able to support new traffic types that demand that quality of service. Then the next step would be that anticipation. And that anticipation comes from sometimes knowledge of the application. So, just as the previous speaker from Verizon, Vodafone was speaking about work in California in insight and innovation laboratories. We have, from an NSN standpoint, we have that as well. And we work with application developers in order to understand those applications better so that we can have that predictability. Okay. But that's kind of a next step, and that is going to be an evolution potentially of the industry.
Right, and so that brings a sort of a new paradigm into your network, doesn't it? In a sense, all of a sudden, the carrier core starts to become aware of the customer and has to have knowledge of the customer, his or her behavior, in order to enhance the experience, and that sort of ups your intelligence quota.
It ups the intelligence quota and hopefully allows us to service, those individual users and applications better. As we talked about, walled garden and dumb pipe in the previous segment. Yeah. Of course, we're trying to change the game as well as a equipment provider, right? And that's one dimension that we see that there's opportunity.
Terrific. Thank you so much.
I think
we do have one more.
You talked a little bit about how important small cell deployment is going to be in the future for you guys, and I'm trying to get a sense of what does that do to capital expenditure, and the second part of the question would be what does a small cell base station like a picocell cost for a carrier?
Okay. Well, I don't want to go into the cost of. I'll let Ken Wirth answer that as head of our customer team. Okay, I don't want to put that out there, but what we gain obviously is the ability to put the network where the users and active users are and subscribers, to be able to increase the capacity. And mainly these first instantiations of LTE networks are for coverage, right? And as the network matures, and you learn more about the users and subscribers that are out there, then you move towards increasing capacity. So our view is that from a TCO standpoint, we've written a paper for vehicular technology, or IEEE, where we've done some studies, and I'd maybe like for you to wait and see some of the results there. But for a certain, if you look at a macro cell and do cell splitting for small cells, there's kind of a magic number, above which, if you stay within those bounds, it's very economical. And you have to assume that, number one, you have strong backhaul, and you have a certain price point with respect to the picos themselves. So it's been from our standpoint, we feel that it is an economical proposition for the carrier, okay, going forward. And certainly it provides the ability to be able to focus network capacity.
Thank you. Mm-hmm. Thanks.
Okay. Well, I'll thank you now. How's that?
Thanks,
Thanks, Bill.